Hi everyone! In this video, you will learn how to identify the 5 other circular functions of theta given one circular function and the location of theta, whether it is in the first, second, third, or fourth quadrant. So, if you want to have fat brains, watch this video and enjoy learning. I also prepared some practice exercises at the end, so I hope you will practice so that we will achieve our goal to have fat brains. So enjoy learning. The generalized definition of the circular functions. If theta is an angle in standard position, Q with coordinates x, y is any point on the terminal side of theta, and x squared plus y squared equals r squared. In this illustration, so here, why is it called the generalized definition? Because we are no longer considering only the unit circle. We have here a circle with radius r. And then we have the following circular functions. So we can obtain this by using the SOHCAHTOA, by drawing this. Or we can also have it using similar triangles. If we draw here a circle with radius 1, okay? So we will be having sine of theta equals y over r. If the circle is a unit circle, like in the previous lesson, this is just simply y. Sine theta is just y, because that's the y over 1, so it's y. But here, if for any circle with radius r, or for a circle with center at 0, 0 and radius r, the sine of theta, which is opposite side over the hypotenuse, is already y over r. And for the cosine of theta, it's going to be x over r instead of x only. For tangent theta, it's still y over x, because this is going to be y over r over x over r, and the r will cancel, and we will be left with y over x. For the cosecant theta, we have r over y instead of 1 over y. For secant of theta, r over x instead of 1 over x. And for the cotangent theta, we will be having x over r divided by y over r, or simply x over y. So this is now the extended or the generalized definitions of the circular functions. Okay, so here they are on the side. And then, since that's a circle with radius r and center at 0, 0, its equation is x squared plus y squared equals r squared. For example, given sine theta equals -5 over 13, and theta is in quadrant 3, find the other trigonometric functions of theta. So we will be using these two given. Sine of theta is -5 over 13. So theta is in quadrant 3. So we don't know the exact value of theta. We just know that the terminal side is in quadrant 3. So it looks like this. And the sine of theta is -5 over 13. Okay. So since sine of theta equals -5 over 13, so sine of theta is -5 over 13. So sine of theta is y over r, meaning to say this is y, the 5, and the 13 is the r. But how would you choose which one is negative? Because -5 over 13 can be -5 over +13 or +5 over -13. you have to take note that the radius should always be positive. So the one that can be negative are just the y and the x, and the r is always positive. And since theta is in quadrant 3, so the y will really be negative. So in this case, this is y and this is r. From this, sine theta is y over r, and y is negative 5 and r is negative 13. And to illustrate that, that's negative 5 for y, and the radius is 13. So we don't know the x, we will identify x. So this point here is x negative 5. So we will use this equation to solve for x. So that's x squared plus y squared equals r squared. X is unknown, y is negative 5, r is 13. So substituting values, we have copy x squared, replace y with negative 5, squared equals 13 squared since r is 13. And then simplifying this, negative 5 squared is 25. 13 squared is 169. So you will have x squared plus 25 equals 169, and then add negative 25 to both sides of the equation. You will have x squared equals 169 minus 25, or that is 144. And then taking the square root of both sides, you will get x equals square root of 144, that's positive or negative 12. So how will we choose if the answer is positive 12 or negative 12? So this given here, that theta is in the third quadrant, will tell us that we should choose x equals negative 12 because the x on the third quadrant is negative. So choose x equals negative 12. And then if you already know your x, y, and r, you can already solve these 5. So the cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta can already be solved. So cosine of theta is x over r. So that is, what is x? Negative 12. And r is 13. So that's negative 12 over 13. Or you write it that way. Negative 12 over 13. For tangent theta, we have y over x. So that's y over x. Y is negative 5. And x is negative 12. So you will have positive 5/12. And then cosecant theta, that's r over y. So that is, r is 13. Y is negative 5. So negative 13 over 5. For the secant of theta, that is r over x. So r is 13, x is negative 12, so that's 13 over negative 12, which is equal to negative 13 over 12. And lastly, for cotangent of theta, that's x over y. So just replace the values. X, negative 12, y, negative 5. So negative 12 over negative 5, that's positive 12/5. So that's it. So these are the 5 other circular functions for theta. So although we don't know the exact value of theta here, we can identify the other circular functions for theta. Let us have another example. Example number 2. Given that cosine theta is negative 4/5 and theta is greater than pi halves but less than pi, find sine of theta, tangent of theta, cosecant theta, secant theta, and cotangent theta. So here we have the angle theta. Here. Since theta is greater than pi over 2 is here, but less than pi is here. So this one is the same as saying that theta is in the second quadrant. This one, because it's greater than pi halves but less than pi. So it's the same as saying it is in the second quadrant. So find the others. So we have there cosine theta is negative 4/5. So cosine theta is x over r. So one should be x and the other should be r. And r is always positive, so the x should be negative 4. So x is negative 4 and r is 5. So the negative 4 for x is here and the radius is 5. And we are asked for the y. So our point here, the terminal point is negative 4y. And we will use this equation to solve for y. Okay, so that's x squared plus y squared equals r squared. X is negative 4, so make that negative 4 squared, copy plus y squared. And r is 5, so 5 squared. Negative 4 squared is 16, 5 squared is 25, so we will have this. For this, 16, copy, and then 5 squared is 25. And then you can transfer this to the other side. That's going to be negative 16. 25 minus 16 is 9. Square root of 9 is positive or negative 3. But what will we choose? Positive 3 for y or negative 3 for y? We have to look at this given, or this, that the theta is in second quadrant, and the y values on the second quadrant are all positive. So we have to choose positive 3. Okay, so we already have the value for y. It's already complete because we just need the 3 values, x, y, and r. So we have already solved for y, then we can already answer these ones. Okay, so sine of theta is y over r, so y is 3, r is 5, so 3/5. Tangent is y over x, so that's 3 over negative 4, that's negative 3/4. Cosecant of theta is r over y, so r over y, r is 5, y is 3, so 5/3. Secant theta is r over x, so that is 5 over negative 4. So that's negative 5/4. For cotangent theta, we have x over y, so that is negative 4 over positive 3, or that is negative 4/3. Okay, so we only need the values of x, r, and y to identify these 5 other circular functions of theta. Okay, let us have our last example for this video. Given tangent theta equals 15 over 8 and theta is in quadrant 1, find sine theta, cosine theta, cosecant theta, secant theta, and cotangent theta. So theta is in the first quadrant, so this is how it looks. So here we have tangent theta is 15 over 8. So that 15 over 8 is y over x. So 15 is y and 8 is x. Okay, so y is 15 and 8 is x. Both are positive because this is in the first quadrant. Okay, so this time, okay, so this is 15, this is 8, and that's 8, 15. So we can find already others with just the x and y, but then, or maybe just the cotangent, but then the others with r, we cannot identify. So we have to solve for r. We have to solve for r using this formula. So we always have to go back to this to find the missing one. So x squared plus y squared equals r squared. X is 8, so 8 squared. Y is 15, so 15 squared. And r squared is, r is unknown, so this remains as r squared. 8 squared is 64, 15 squared is 225, equals r squared. 64 plus 225 is 289, equals r squared. And taking the square root of both sides, we have 17. So we no longer need to put plus or minus 17 because, as what we have said a while ago, radius is always positive. Okay? We only have negative for x or y. But for the radius, it is always positive. So we already know r. We can already solve the 5. So sine theta, cosine theta, cosecant theta, secant theta, and cotangent theta. So for sine, we have y over r. So that's y is 15, r is 17. So that's 15 over 17. For cosine, that's x over r. So cosine of theta is x is 8, r is 17. So 8 over 17. For cosecant theta, we have r over y. So r is 17, y is 15. So that is 17 over 15. For secant theta, that's r over x. So r is 17, x is 8. So 17 over 8. And for cotangent theta, we have x over y. So we have x equals 8, y equals 15. So that is 8 over 15. So that's it. So here ends our discussion of the examples in the extended or the generalized definition of the 6 circular functions. So after this, I'm going to give you some items for your practice, and I'll be also providing the answers. So please get your papers and pencils or ball pens and practice for you to have a fat brain. Thank you for watching this video. I hope that you learned something. Till the next video, bye-bye!